Hello, welcome to the new logical section of our entire playlist. Before we go and start about what we are going to do in this section, I just want to recap of what we did in the last one. So remember, in the very starting video, we sort of said, hey, these three concepts, if you nail it down, you are basically set for your career, start of your career rather in the embedded system. And the first one there was C, like C, basic concepts in C, how do you design a program and how the memory layout of a C program is, and some bits on pointers and all. So we kind of went over that. The second section we want to sort of shed some lights on. Well, maybe I'll give Piyush some time to catch because obviously.
Sure, thank you.
Yeah. Second one would be the OS concepts. What constitutes an OS, why it is required, and the nitty gritties of what makes an OS tech, basically. So that would be covered in the later part of this playlist. But the third one, which we had discussed in the opening sort of bird's eye view video, was the general embedded concepts. And this is what we are going to tackle in this section now. And to shed some light here, general embedded concepts would include physical memories versus virtual memories, your interrupts, your caches, and all the other your IO buses, etc., and all the concepts which are required to sort of grasp a simple embedded system. And yourself, please? So all these concepts which are required to grasp a layout of an embedded system, and if you have understood those, you can maybe build your way forward to then taking on a complex embedded system, meaning Raspberry Pi or BeagleBone boards. But I think, and we both think, sorry, that these three major sections, once sort of nailed down, will give you will be the fodder for the more challenging topics or case studies which will present later.
Right. And Mohammed, can I then go ahead and also add few points from my
Sure.
own?
Yeah, definitely.
So, a good way to think about all of this is, well, centrally there was a CPU that would take input and process, and give out the output. So the section that we are focusing on right now goes into the general embedded stuff, and this primarily talks about all the hardware pieces that are involved. Typically there would be like a CPU. Okay, just a moment. There would be like a CPU with some interrupt lines, connected to the memory system, and take some inputs from the peripherals and then give some output through its GPIOs. So we'll talk about all of those now. And as Mohammed was mentioning, well, we started with this just so that you understand the relevance of this language and what are the key concepts to master. And now on the side, you can kind of go and pursue this, right? Develop that muscle to be able to think and write programs in C. And then we are now going to spend time on this. And as you'll see later, what happens is the more you know about this, the more operating system naturally makes sense. So eventually, after we discuss everything about the general embedded concepts, the hardware, the CPU, GPU, the MMU, the MPU, all of that, the moment we discuss all of that, it will naturally make sense as to, hey, a program can directly be run on this hardware, but then we are not utilizing the hardware to its fullest. And then how do you go about, so to speak, extracting the juice out of the hardware so that you get the most battery life and you get the most functionality out of a CPU, which is running at a very low clock speed, let's say. So the concept of OS then naturally kick in and make sense. So you won't have to kind of force fit the concept of OS on top of a hardware. It'll just naturally kind of evolve. All right, so yeah, that's what I want.
Thanks for putting it very nicely, Piyush. And while we were starting this series, our natural order was 1, 2, and 3. Like we wanted OS concepts to be sort of taken first, but then when we sat down and sort of planned the content, we thought like, hey, it makes sense to first tackle the general embedded concepts first, just because whatever we discuss here would naturally make sense when we delve into OS concepts later. For example, if you know about caches, memory, and the atomic operations, the bits which the operations which have to be performed in a single go, it will naturally make sense when we talk about semaphores, mutexes, and certain cacheable operations which are provided by OS. So yeah, that's the change in order as of now. And with that, let's
and actually it's a bit of a flip flop in the sense that you need to know some embedded hardware or embedded components knowledge to be able to talk about OS. For example, given a timer and a CPU, can we perform round robin and execute multiple programs? That would be one. But then as we start to develop the operating system a lot more, we run into issues like two programs touching the same memory, same region, race condition. Then the question comes, hey, how can the operating system guard against the race conditions? And all of a sudden, you will notice, and we'll reiterate that the OS design also kind of, over time forced certain
hardware changes.
Yes, hardware changes. And those kind of hardware changes, we'll talk about as we discuss about the operating system. So this section is going to be heavy on embedded system components. And the next one is going to be OS and a revisit to the embedded components as and when required. All right, I think then with this pretty much lays out the plan that we have for this section. And starting next lecture, we can dive into the actual details.
Yeah.
Does that sound fair?
Yep.